let's take a look at our problem of the day. And the problem of the day says parallelogram with area of 63 square inches has base that is 2 more than the height, which basically means 2 more inches there probably. Find both dimensions using algebra. Oh, some of you said, I think I could figure that out in my head. Well, you probably can. But let's see if we can apply some algebra to it also. But a parallelogram with area of 63 square inches has a base that is 2 more than the height. Find both those dimensions. Let's use some algebra, all right? So let's take a look at what's going to happen. Got a figure to go along with you here. And again, we're starting with the area. And our area is in square units. In this case, square inches. We've got a base down here at the bottom. And we have a height. Now folks, we got to be careful with this. The height is not a dimension of the parallelogram. It is not. This is slanting. The height is one of these things that makes a nice right angle with the base. And I'm going to drop it right from here. It looks like as good a place as any. You could put it anywhere across through there because these run parallel. That's why they call it a parallelogram. So these little parallel lines are going to exhibit a base there. Now, if you went the other way here, you would have another base and a height working together, but we're going to go with the two that are really pretty obvious here, all right? The horizontal one, and by the way, remember what I said? These come in perpendicular, which means you got to have a right angle. So we'll call this height for lack of anything better. That's our dimension of this parallelogram. Is what we want to work with. Now, let's talk about this base. You know, base sounds like a B, right? And for some of you saying, I think I've heard of that B times H formula, Ernie. Yeah, most of us probably have. And if you haven't, now you get to. But the problem is, we really don't know what either one of these are, but we do know there's a connection to the height with the base. The base is going to be 2 more inches, in this case we're using inches for our units, than the height. So we put H plus 2. It's pretty straightforward. And by the way, just to help us remind and remember things, the height is H in this problem, all right? I'm going to put out right there by my picture, yeah. The base is equal to H plus 2. So we're kind of defining our variables. We've got 2 things that are missing, things we're looking for. What do we do with them, you say, Ernie? Well, there's this little crazy formula. No, it's not really crazy. It's pretty straightforward. That says if we want to find the area of that parallelogram, that it's equal to our base times our height. Now, I've already changed this B into a H plus 2. So we're just going to take the B out of the picture and put the H in front times H plus 2 and distribute in just a second. Oh, by the way, did I tell you what the parallelogram area was? I sure did, right there. Important note right there. Area of 63. So we've got a number. Some of you are going, are we going to have a number? Well, we got a 2, we got a 63. Now let's see what we're going to do with all the good stuff. So we've got 63 over here equaling to, I'm going to put it in here, H times H plus 2. Just switched them around a little bit. And I replaced the B with the H plus 2. So now we're in business. We're in good business here. Let's see. 63 hangs on tough. We're going to distribute. And we're going to get some H's out of this. Actually, we're going to get H squared. And we're going to have 2H going there. Now, before we go any further, let me caution you big time. H squared and 2H do not combine to make something like 3H or 3H squared or 3H to the third or 2H. I mean, you get all sorts of combinations that are wrong. This is where it has to stay. You cannot split that apart, all right? Yet, all right? So let's see what's going to happen. Now, we're going to drop out the lowest, thank you. And we're going to make a 0 up here because that is, folks, what it takes. So if to do that, we've got to subtract 63 on one side, which means we've got to do it the other. So here comes our expressions. Looking kind of crazy. I told you it's going to be a little wilder problem. So we got a minus 63 on the end. And notice we've got this H squared plus 2H minus 63. Now, you guys who haven't taken Algebra 1, don't get nervous, all right? Because you're going, where is he going with this? Little Algebra 1 technique. We're going to factor this. We're going to run a factoring through that. Now, those of you who've had Algebra 1, you go like, ah, yeah, I see what we're doing. And the geometry application there, all right? So let's see where it's going to go. We've got a 0, and like I said, you know, this is our big summer school, getting close to summer school type thing. We're getting to the end of the semester, so we're hitting some harder problems here for you guys. This is geometry / algebra moment. Let's put let's break this thing into two binomials. This is a trinomial, by the way, and it's pretty straightforward because we're going to reverse that foiling process, that distributive property that I call the double barrel distributive that gets us from two binomials to that trinomial. We're working in reverse. So I need an h and an h here. I also need to find a way to get 63. Now, this would be where we start thinking of how do we factor 63. And the numbers we would choose could be, well, 7 and 9 are the times tables that we've used. 7 times 9, 9 times 7, however you want to look at that. And there's also, goodness, we could do 21 and 3, and we can do 1 and 63. Those sound kind of painful, don't they? And I don't know if they'd help much. But what we want to do is get a 2 in the middle. We want to get 2 in the middle. So you say, well, Ernie, how do we get 2? We're going to have to look for subtraction because our signs are going to be different. So I'm going to put a plus and I'm going to put a minus right there. And what I got to do is figure out which factors go where. I've got 7 and 9. I'm really narrowing that down because the difference is 2. And that's where I want to go. So I'm going to put a plus 9 and minus 7 because you know what? If I take 9h and I subtract 7h, I get my plus 2h, which is good news. The bad news is I've got 2 answers to play with, or maybe I do, maybe I don't. Let's take a look. I have, first of all, I'm going to move them over here. I've got h plus 9 equaling to 0. I've also got h minus 7 equaling to 0. Now keep in mind, we wanted to be able to come back and say base times height. But we also, if we'll notice here, when we move this 9 over, subtract both sides, we've got h equals negative 9, which is not really a good answer because we can't have a negative height. And that's going to give us a negative base, which looks even worse. So say goodbye to that one. Let's add 7 on this one to both sides. And I believe that will give us h equaling 7. And that one is good because if we put a 7 here and we put a 7 plus 2 there, we get 7 and 9. And guess what? You have exactly. You've got the final solution of your dimensions. Your height is 7. Your base is 9. And those are your 2 solutions there. Again, yes, we could have done that in our head if we know our times tables. And actually, if we know our times tables, multiplication facts, and all those good things, it still helps to get them if you do it this way. But a little algebra application, since we did ask for that, we want to just show it there, all right? So there's your problem of the day.